It's a pleasure to have you here. Can you tell us a little bit about yourself and what you do?
Yeah, thank you for inviting me. So I think my story started like at school when I did a lot of mathematics and computer science and like participate in different Olympiads. So I just moved from usual school to more like specialized school with a focus on mathematics. And so there was like a great community where you can just solve a lot of problems and you can always ask a question. You will always have an answer for it. And then I moved, so as like spent a bunch of time on solving problems, learning about algorithms and data structures. And then I went to a college where I studied applied mathematics. So it was kind of cool. I mean, I like it, but from the first year, I just understand that it's too theoretical. It's not applied at all.
Mhm.
So I started looking for a job, and there were a bunch of different options. You could go to internship at Google or Amazon. You can also just working part-time on small Ukrainian company. But a friend of mine just speak a lot about zkSync and small startup in crypto. So it's like very curious what is this? Because that time it was like, what is Bitcoin? What is Ethereum? And everything was so mysterious to me. So it was sound like a rocket science. And at the same time, it was very interesting because it was so like interconnected with pure computer science. So yeah, I guess it was just very interesting in what zkSync do, and also I jumped to the website, and there was a slogan where trust mass, not validators. So it's like, yeah, it's like it sounds super cool. So I want to be in. And I had interview with Alex, our CEO, and the interview was like, "Can you solve the problem?" And like, okay, okay. You split the problem in like part, so it's like smaller part and solve it, and then another one. And Alex was talking about, yeah, yeah, you don't have experience, it's fine. The only, important thing is that you're smart enough to figure it out. So it's like, wow, it's exactly what I want because on all other companies they're saying, no, no, but you need to have 1 year of Java, 1 year of C++, whatnot. So it was just different vibe. And yeah, it's how I joined Metro Labs, a company that is building zkSync. And it's my first job. Yeah, so it's like working 3 years in crypto for now.
Yeah, it's a very cool first job.
Yeah, I think it was just lucky.
So you said it was a small startup at the moment. Did you have an idea of exactly what they were trying to do and how big it could become or like what that entailed back then?
Not really. So it's like when I joined, I was actually reading a lot of books, and my task at work was like, yeah, can you read Ethereum, yellow paper, or like, can you read about this paper, write a bit of circuits, or just figure it out what is API and SDK. So a lot of just simple computer science stuff, but also some advanced like ZK circuits. So I did research on both area and started doing something on more applied after time passed.
Cool, cool. So what was your evolution in the roles from when you started as zkSync and what you do now?
Oh yeah, so it's like when I started, I was doing mostly Rust because so we had like back then we had circuits written on Rust, we had server written in Rust, we have TypeScript that is for tooling, and so it's like I was doing server side work. Oh, it's like and Solidity, of course. Yeah, Solidity for the smart contract. And back then, Solidity was like, oh, there's a lot of money inside. I don't need to keep it. Like I don't want to touch it because it's so, dangerous and you don't have experience. So no, no, I just will do something else. I was doing Rust code and some tooling in TypeScript. It was really enjoying because you just try, you understand what is a node on blockchain do, and you try to understand what is decay, all the level of abstractions. So yeah, it was very interesting, but I think that I spent like 1 year doing this job, and then there was my first task on Solidity. So it was kind of big task. I spent like 1 month, make so much over engineering. I bring a lot of data structures. So everything that I knew from Olympiads, I just bring to Solidity and say, yeah, I optimize it very well, so you can use it in production. Like on the review, there's like people, whoa, why do you bring so much complexity? Back then, I was like, no, but it's fine because I understood what I'm doing. Right now, I was like, no, I did not. So it's like, yeah, but so it's like my first task on Solidity, and basically I just start from that. And after after this, I was working on smart contracts for zkSync Era that is currently deployed on mainnet, and also porting some upgrades for zkSync Lite. So it's a previous version of zkSync.
And you specialize in the security side of things, correct?
Yeah, but it was not always the case. So it's like when I did a job for protocol, so basically writing Solidity contracts, also researching for account abstraction, message passing between chains, all of this. I was really passionate about security, and I was like a bit concerned about every piece of code. So it's like when I did review, I think that I was looking into code and try, to break it. It was intentionally my idea to break the code, even if it's fine. Sometimes you can just find something very suspicious, and you want to go deep into it. So it's like it was how I started to take the security role. Did a bunch of internal review, find a couple of external bugs. And so after that, I just understand that it's probably mine. And just probably a month or two ago, I switched from protocol team where I writing smart contracts to a security team when I actually make design review or, challenge the ideas, all of this.
And how was that transition from the building side to the security side? What sort of mindset shifts did you have to make?
I don't think that I made any shift in mindset because when I wrote the smart contracts for the protocol, I was always concerned about security. So it's like when you write something, you need to be very deep into security as well, because after that you will have audit. You don't want to be in the position where you have three criticals, right? And also, you just want to know if at any case you just need to deploy contract and without any external review, it will be fine. We don't do this, but it's just you need to have impressions that it will be fine at least. So it's like you need to understand everything and making design review as well, but it's a bit of different job when actually you sit down and writing smart contracts, or you challenge the ideas, you make review, you're working more on the abstract level where, okay, how we design the component of the system, how secure should it be, like what we can add as additional level of security. So
Right. So it sounds like you've been naturally more geared towards security from the get-go. And if someone wants to get better security, but they don't have that initial propensity to it that you have, is there any piece of advice that you can give those people that are trying to be more security minded?
yeah, sure. I think that the first that you can do is basically start to understand how EVM works. So for me, it helped a lot because so I was looking into Solidity code and trying to understand how it's executed. And there's a bunch of resources that you just go and take a look into each of code, how it works, how much gas it consumes, all about EVM. And as soon as you understand EVM, you will understand a lot of potential security issues. So it's like as soon as you really deep into it, then you can actually find a lot of bugs. This is the first step that I would do. Another step is obviously doing security review for, let's say, Code4ina or Immunify. Probably Immunify for a lot of people will be very challenging, but Code4ina seems fine to me because there's a lot of contest right now. When I started doing Code for Arena a year ago, there was like one or three contests just running at the same time. But now I see like five, seven, and there's other platforms that also very popular. So you can jump on the smallest bounty, and try to understand the protocol from the very beginning to be in advance on it, try to find bugs, and then read the disclosure report and etc. So it will help a lot.
So what is zkSync, the company you work for? What is it and what does it do?
Yeah, so we are working on scaling Ethereum. And basic idea is that yeah, Ethereum is very cool, very decentralized. It's what we like on Ethereum. It's why we're not moving to any other chains. But at the same time, when you try to be very decentralized, you will have some limitation. And this limitation on Ethereum is like, okay, it will have 12 TPS, but not more, right? And also, yeah, we know about problem with Ethereum because it's very expensive, it's very slow, but we're using Ethereum because we want to be secure. And the idea of zkSync is to bring advanced cryptography of zero knowledge proofs or validity proofs to actually scale Ethereum. And yeah, it's what we did, I think, 3 years ago. We made simple rollups. It was a rollup for payment, NFTs, and swaps. So the idea was that on layer one on Ethereum, you could just deposit funds into zkSync. Now it's called zkSync Lite. And on this rollup, you can take the funds and make transfer to any address. So it will be much cheaper because of this advanced technology. You can prove execution of the rollup, and the verification on chain will be very cheap. So yeah, it's like a basic idea.
Could you describe a little bit what a rollup is?
Okay, what is rollup? So as I said, the idea is that you want to prove okay, you want to prove the execution. There's two different ways how to do it, but let's say that you somehow can provide the proof for Ethereum that execution is correct, right? And you also want to publish all the data for users to understand what happens in the blockchain. So Rollup is basically a separate blockchain that is connected to main chain as Ethereum for layer one, we call it, or for Rollup it's layer two. And you connected it via bridge, and the state transitions that you can do always should provide the proof of execution and all the data that is needed to restore the state of a blockchain. So at any point of time, you could actually say, yeah, I know the execution is correct. And also you can just take a look into the data on chain and saying, yeah, I know the state of the blockchain. So you are like pretty sure that it's always explicit what happened on the blockchain. You know that there's no fraud. And yeah, it's a basic idea. So and also there's some um, some properties that need to be on the rollup to be a rollup. So users always should have ability to exit from rollup to Ethereum. So it's saying that we inherit security from Ethereum.
Right. And there's other types of layer twos, right? There's other types of rollups, other types of layer twos that are not actually rollups. We have sidechains, validiums. What is the difference between the zkSync rollup and layer two?
Oh, it's a great question. So it's like the problem is what security of money exactly. So it's like you can you can bridge funds to any sidechain, and usually sidechain means that there's a bunch of private keys via one multi-sig that's signing a message about validity uh, of the chain. So if the keys of multi-sig will be stolen, your funds will be stolen as well. So it's like all the security is based on the a bunch of private keys. It's a difference. I think that it's a case for many bridges. It's not only it's not always a case when we think about like side chains, but also about the bridges itself. Because there's also security assumptions that you get from bridges. It's usually just a multisig. And what is different for the rollup is that we mathematically prove the execution. So you don't need to trust us. We just provide the proof. You can verify it and say, yeah, it makes sense to me. And if the implementation of the rollup itself is correct, that is, audited, we have a bug bounty program for $1 million for ERA and $2 million for Lite. And if it's correct, then you can assume that security is the same as in Ethereum. So it's like you don't need to trust us. There's no single point of failure.
Right. So a sidechain is mostly control. The security relies more on private keys, so it's not mathematically secure. And there are other types of ropes as well, like which are more similar to zkSync, but because they're not a sidechain, but there's some differences between there.
Yeah, there's some. So for optimistic chain, it's actually a very simple idea, and I think it's a brilliant idea. If in the world where there is no the key proof, I would say it's something that we should to use. But as soon as we have the key proofs, we have something better, more scalable, and so you don't need to use optimistic approach no more. But for optimistic approach, is basically saying that, look, I put something on chain. Here's the data. If you think that it's incorrect, you can prove that it's incorrect. So it's like, and you have a window, like let's say 7 days, when you just watch the chain and saying, oh, okay, that's a fraud. I will prove it. And yeah, it's what's the optimistic approach. And for ZK, you're saying, no, you don't need to watch the chain because we just provide the proof, and you can just verify the proof on chain.
Yeah, right. And so those chains are still there's still a pretty big difference, I would say, because one, you're assuming the transactions are valid, and the other one, there's no assumption of anything. They're always getting validated. But then there is also validiums, which are a little more similar to ZK rollups. Perhaps you can make what is the difference between validiums and ZK rollups?
Yeah, so as for a rollup, you need to publish all the data on chain, and that would mean that if you just taking a look into Ethereum, you will always get the data, you will always be able to restore the state. But what you can do is to publish only a proof on chain, and data you can store on other storage. You can, you can get eigenlayer, or you can get anything like a sharding of data that is very popular right now, and you can just saving data on one data accumulator, but proof sending on chain. This way, if malicious validator wants to stop the chain, it could stop the chain, but not steal the money, because he can't make a fraud. He can make a state transition that is incorrect mathematically, but he can just say, "Oh, I don't know the data," and no one will be able to restore the state. So it's a different security assumption, but it's more like acceptable ones, I think, because so the yeah, so basically, if you're saying that you only can stop the chain, what you will do with it, right? There's no incentive to do it. And it's still to be researched, of course, but it's much better than having optimistic chain with no data availability layer, because in that case, you can make a fraud and say, yeah, I just sent all the money to my address. And no one can prove it because data is not available.
Right. So there's all these different ways that you can do rollups. And why did zkSync decided to go with this type of architecture that you guys are doing? What are the implications of such system?
I think that it's the only viable way to do secure chain. So previously, a lot of people just experiment with Plasma, with optimistic chain, with optimistic rollups, and it's pretty popular even right now. But back then, it was not obvious that ZK will be scalable enough to actually compute something like EVM or any other virtual machine. And 3 years ago, when I joined, it was like, no, it's crazy idea. We will not do it because it's impossible. Right now, we see that we have a huge increase of performance for proof system, and basically you can prove whatever you want. And I think that Alex, um, our CEO, he had a pretty good vision for future, and saying, yeah, it's not not scalable enough right now, but in 1 year, 2 years, and he was right. So with ZK, you can do a lot of different interesting stuff. You can have a multi-rollup structure, or you can hyperscaling. You can have layer threes. Um, you can even try to experiment with data availability layer, or you can prove any execution. And for optimistic and other approaches with game theory involved, it doesn't work. It just doesn't work. So it's like what the problem? there's a lot of different experiments, and you say, okay, here's one problem, we solve it. There's another problem, we solve it, and like it's always something with a lot of assumptions that you need to take. And when you bring zk, it's like the only assumption is implementation is correct.
Right. And you mentioned hyperscaling. What does that mean, that hyperscalability? I know you guys are thinking modular frameworks and talk about hyperchains and hyper bridges. What does that mean exactly?
So I think that, yeah, it has a lot of different meanings, but also because right now I see that a lot of literature try to experiment with hyperscaling in some different forms. But for us, it's more like you can have a couple of rollups that has a connected with one bridge, and they could just have a message passing between each other, like in the sharding model, very cheap and very secure. So if you have one implementation of the rollup, let's say there's a few instances of zkSync, and both of them, like you can just bring money from one to another very cheap. You don't need to go through layer one. Also, it's just different instance of zkSync, so you can have mixed, data availability layer, or you can think about making your own application specific layer on top of zkSync chain. So yeah, it's a basic idea that you can make it like a multi-world of chains instead of having one zkSync instance.
Right. And all of that is powered through validity proofs, right? So you wouldn't have to make any assumptions.
Yeah, exactly.
And what are the security implications of such system? What are the challenges and considerations a project like that has?
Oh, like, uh, of, yeah, of course I think it's okay. So it's like you can take the current implementation of zkSync, and it's basically was developed for, to be secure, to be to have a great user experience and all of this, of course. And you can just take it and involve it in more like generalized way. So like saying that people can copy paste the code and it will be, it's open on GitHub. You can just make a Git clone and then start working with it. So you can develop your own chain. Like similar to what OpenZeppelin did with ERC20 tokens. If you take a look into OpenZeppelin site, just have a button to, yeah, I want to create ERC20 token. I want to have this extension and another one, and okay, deploy, boom, and it's deployed. So it's like the same that I would expect for rollups in the future. If you want to develop your own chain, you can just have this constructor for the rollup, and it's what we do with zkSync, like adding a layer of additional extensions and thinking how they should be interconnected together, what validity proof we should use, like how to verify it, and how to make it cheaper, how to make message passing between them. It's all extension to current architecture, right? But the main core part is the same as it was.
Right. So the goal is to one day make it as easy to deploy a Zk chain as it is to deploy a ERC20, basically.
Yes.
Cool. So zkSync has these properties that it doesn't need to rely on any assumptions and it can be hyperscaled, right? But what are some of the cons from zkSync that another type of rollup has, for example, optimistic? Are there any positive sides to choosing an optimistic rollup against a Zk rollup?
I think that for a long time, optimistic rollup was much cheaper than actually zk rollup. The reason for this is because they don't really need to prove something on chain, but they want to be optimistic that just sending data and assuming that everything is correct. And in the worst case, they will prove the execution, they will have a challenge period, but if everything is okay, it's cheaper. Yeah, it was for a long time, and now I think that it's a bit changed because so there's the interesting properties for optimistic rollup. You always need to store data that not only enough to restore the state, but always to re-execute transaction. So you just need to store the all transaction altogether on the layer one. And it's for a zk rollup, you can also do this. Of course, you can just store transaction and say you can, restore the state, you can re-execute transaction. But what you can also store it, you can store just the difference between storage from previous block and current one. So it's like saying that here's a plot that changed from value x to value y, let's say, and you store it on chain, and people can take a look and say, yeah, it makes sense to me. I can apply this storage changes to Merkle tree with storage, right? So, and still you will have all the information to restore the state. But the data that you publish will be much less. It's what we do with on zkSync. You can also think about um, Oracle updates. It's a pretty simple use case, but it's very popular right now. So if there's one Oracle that updates a slot for like every second, it will need to make a lot of storage changes. And on Ethereum, you will pay for every storage change. So it's like, yeah, I pay for this and another, and like for 100 of storage changes. It will be very expensive. On zkSync, you can just make all of the storage changes and pay only for one of them because only one storage change will be sent to Ethereum. So it's a different on the data availability model, what you can store on chain, what data you can store in chain, and it will be really cheaper or more expensive depending on the protocol. But from what we see right now, if you accumulate enough data together, so it's like if block contains enough transaction, it will be cheaper to have storage changes.
And when you started, you mentioned it was zk Lite, and now it's not called that. And what changed between what was then and what is now?
So for back then, it was just very simple rollup. It was like a proof of concept, I guess, for what we can do with zk proof. And the idea was that you can actually transfer money to zkSync by depositing through layer one, and then all of this money you can transfer to inside the rollup. So it will be cheaper to transfer inside. And yeah, it was actually some pretty good use cases was for the rollup back then. It's like you can make a donation, yeah, right? So you can deposit once to rollup, and then you can make transfer for one project you want to donate. It was used in Gitcoin grants actually. So you can use to donate to another one, and you can make a lot of donation. Um, but yeah, deposit on layer one is very expensive, and transferring on layer two is very cheap. So if you make enough transfer on layer two, it will be cheaper for you than transferring on layer one.
So back then it was a simple specific application for zk Lite. And what can you do now in zk era that you couldn't before?
So it's a generic virtual machine, more like EVM specific. So you can just work on Solidity smart contracts and deploy it on directly on zkSync. And what it's really impressed for me because the technology involved so much that currently you can just prove the execution of virtual machine, and you don't need to think about application specific chains. Like no more. Yeah, probably we will have use cases for application specific chains in future for like trading, let's say, or games probably. But for general purpose rollup where you want to have a DeFi, you want to have some other application altogether, you want to have communication between them, you can just deploy uh, what is on zkSync here. Right?
And you mentioned application specifics for gaming. What would that look like?
Um, it's actually I don't know. It's like I'm not very deep into games, but I assume that people figured out how to make separate chain for gaming, and it's very inconvenient to make it on Ethereum or any other chains because they want to have a really big throughput. So it's like they want to have a million of transactions per second. They only cares about items on the game, so yeah, I would assume that they will need to have a chain for this. Probably it will be storing some items, but also providing a proof of execution or proof of finishing of the quest or something. So you can
Mm-hmm.
just and then you can copy paste the data from one game to another one, or you can change the server and you will have a proof that you actually played it your own, but not making a fraud for the server. So yeah, it should be some kind of mix of what we see right now that people try to bring into on-chain, but and also off-chain gaming, something in between.
And I could use the current zk stack to deploy a chain like that.
Not yet, not yet, but I think we will see it much more in future. So we just release our zk Credo and zk Stack technology, but also working a lot for actually providing, it's more user-friendly, developer-friendly, and people to actually be able to deploy everything in place.
Can you elaborate on what the zkSync is?
It's a set of um, goals that we put for zkSync itself as what we want to achieve with zk technology, as we assume that zk is the only technology that can bring scalability in in the forms that we want to achieve on the blockchain, and it's the only technology that can actually involve blockchain to something that can be used widely in the industry. So yeah, it's a, like um,
So it's basically a manifesto
yeah, it's
about
basically
the goals and morality that this type of technology allows and embodies.
yes, exactly.
I'll leave the link below if you guys want to dig into it. And zkSync obviously stands for zero knowledge, right? And what are zero knowledge proofs? What does that mean?
Okay, so for zero knowledge proofs, it's so zero knowledge means that you could make a proof of something without actually revealing the information about it. So assuming I have a, let's say, big number, I know that I can split it into, a multiplication of two different numbers. But if I if you're just saying the one number, like if you're saying this, if I provide you two numbers, you can say I multiply them, and I know that it actually is this one big number. But if you don't know how what number you need to multiply, you will not actually be able to say whether I know the numbers itself. But with the key proof, I can make actually proof that I know both two numbers without revealing it to you. Another cool feature of the key proof is that you can prove something, but verification of it will be really cheap. And even if execution is arbitrarily big, so you can prove one virtual machine or 10 of them, or you can make a proof of virtual machine, then the verification will be as cheap as proving something very small. So it's what we use on zkSync because so the trace of transactions that we prove, it can be very big. So it's like you can have 100 or 1,000 transactions, but at the end, you just create one proof and verify it on chain. Even if you want to provide the proof for two blocks, we can make one proof for it. If you want to provide a proof for the whole history of Ethereum transaction, we can make one proof. Of course, it takes some time to actually generate the proof, but besides that, it's feasible to do.
Right, and there's different ways you can do those proofs, right? There's different types of ZK technologies. What type of ZK do you does zkSync rely upon, and why?
Yeah, so currently we use a Plonk, some kind of extension to it, but the basic idea of Plonk that we take, and it's currently deployed on the zkSync Era. It's well battle tested because we use it on zkSync Lite, we use it on zkSync Era, and it actually did the job. But I think when just a month ago, or like more like 2 weeks ago, we published Bochok. It's a new proof system that we developed for a long time. I'm not cryptographer, so I couldn't go deep into it, but I just saying that um, it's a Stark proof, not Snark. Also, don't want to spend much time on it when describing all the difference. But the cool feature about this is that proof is very cheap to actually generate, and we can use just consumer GPUs to generate a proof. It's something that we want to see for decentralizing the network because we had a lot of GPUs from that people used for mining and they don't know for what they can use it right now, right? And for the key proofs, we used big data centers to actually generate the proof, and it was not always as cheap as we want. So yeah, and with new proof system with Bodger, we could bring all these consumer GPUs to actually do a work for the scalability of the network.
And that would allow anyone to run these proofs on their home computer, right?
Yeah, I think so.
And what the projects you've been working on at zkSync lately?
So yeah, I think that actually I did a lot of further protocol. I was writing smart contracts and designing bridging or thinking about account abstraction, very interesting task in general. So it was more like designing the protocol itself and designing how you will develop each component for the state transition, or what you will say is that yeah, we need to store funds in which contract and how. Also designing the governor feature, how it should look like, right? So you always have this private key and multi-sig, but you can always think about different implication of security for it. And usually people just saying, yeah, yeah, we have one multi-sig and like 7 out of 10. If kiss with us, it's all fine, but if not, we are fucked up. And we are saying a bit different. We try to think about all the implication. If key is stolen, but there's no incentive to actually reveal that you have a key, or like what you will do in different situations, how you prevent hacks. And yeah, it's what was a part of my job.
Can you dive into a little bit of the account abstraction work that you did?
Yeah, so for zkSync, we have a landscape for actually experiment with EVM, but not even EVM, but execution itself. So if you think about blockchain, from the very beginning, we had Bitcoin. It was more like application specific. Then we had Ethereum, the smart contracts. It's very cool, but it was like not perfect because you have this one single point of failure with your private key. And basically, if you want to use your private key for gaming or DeFi, and you just need to store it somewhere, you need to have or seed phrases, right? It's very inconvenient. You have to describe to my grandfather that there's a couple of words that you need to store somewhere. Um, and it's actually what secure your funds. There's no one from bank who will call you in case of emergency. And the experience for users was not always great. For more advanced users, probably okayish, but for billions of users that we're saying that we want to have on chain, it's not the case. So account abstraction is a feature that allow you to get out of private key to something more user friendly and actually make an abstraction over account. So saying that, okay, authorization of account, you can just develop it by your own. You can develop the execution of your account by your own. And now you can have a different interesting ideas. So you can have a session keys. It's imagine you play a game and you want to make some interaction with the game, but you don't want to sign every message on MetaMask. It's very inconvenient. And you just want to store it somewhere in browser storage. But if you just do it, you can lose all the funds. It's not very cool, right? So you want to you need to create another wallet and transfer funds to it, and then take this private key and play. But with account abstraction, you can just say, yeah, yeah, add new key, and now you have one key that can call only specific function with specific amount. You can have a restriction on it, and you can play a game, make an interaction, and your browser will send a message instead of you. And you don't care about that because there's a limited amount of funds that can be stolen. Or you can think about multi-sig or 2FAs that you can enable with it. There's a Argent wallet that has very cool user experience. So it's all about user-centric roadmap when you want to bring great user experience and be on the safe side as well. So it's like all together.
Yeah, so that would be taking a bit of the administrative burden of a user and allowing him to do whatever he wants to do without having so severe consequences if something goes wrong. And how is that implemented in zkSync? How does that look like?
There's two different ways how you can implement it. You can implement it on top of the network. It's what Ethereum Foundation do right now, and you can have a smart wallet that will have relayers, and it's a one way how to do it. I think the reason for it is because for changing something on Ethereum, it's very hard. You need to, be aligned with the community and try to be backward compatible. And for the Sync, we're more flexible. we don't want to break things, but we can experiment with something, and we can always add it on top of the network. So it's a case for us. And we did it in more like natural way to make it from the core part of the blockchain. And so it's like this, we called it native account abstraction because it's not that we try to add on top of execution with layers on top of it, but instead we're doing it as a design of the protocol. And by that, so if you send transaction to zkSync mempool, there's two different types of transaction. It's either Ethereum transaction that can be used for EOA accounts with private key, but you can also use a specific type of transaction with which you can send transaction to smart wallet. And this transaction will be processed by mempool, by our sequencer, and this transaction will be validated by smart wallet and then executed by smart wallet. So we kind of delegate the functionality of validation of the signature, nonce, and all of this for the wallet. Yeah, but it's still something that is managed by the protocol, not some extension to it.
Yeah, cool. So I could choose to use a account abstraction or not, and that's implemented natively instead of being an extension for zkSync.
Yeah, of course. Yeah, you always can choose because it's Turing complete network, so you can just make some extension on top if you want, but it's still you can use a native feature.
Awesome. And through implementing all of this, I'm sure you had to increase your skill set significantly from one task to the other. And how do you, what's your approach to learning new things and tackling new challenges?
I think that it's more like a natural way how we take challenges because with Xing progressed, I took more responsibility and you just to learn a lot about different areas. So I started doing smart contracts and then I just jumped on security. Actually, very fun story because I was thinking about jumping on Immunify or Code4Rina for a long time, but was like not very confident on my skill. There's a lot of people who's got of solidity and is not much more than me. But the story that I had is like I was thinking, yeah, I can, but not now. And then I did the code review for just usual PRs. Yeah, you just a part of your job to make a review. And there was a code that I took a look and like, oh yeah, it's like small library. I probably will try to break it and spend like 10 minutes and say, oh, here's the bug. Please fix it. And my colleague said, no, but it's not my bug. It's OpenZeppelin library. It's like, what? I was like, yeah, it's OpenZeppelin. So I jumped to Immunify and like, okay, submit the report and say, yeah, it's valid submission. It was medium severity issue. It's my first bug that I was paid for. And then you start, working more and saying, yeah, probably I'm confident enough to jump into security. And it's always the case with a job in Web3 space, I guess, because you just try to do a bit more, and then if you succeed on it, you will start working and do more and more. Of course, it's not good to take security responsibility when you're not confident and you uh, can miss a lot of bugs. But at the same time, if you progress and take it uh, a bit and a bit more from time, it will be fine, I guess. Yeah.
Yeah, I think that's a good point to make that if you don't actually try it, you don't really know how good you're actually going to be. But if you just give it a try, you can just have a actual sense of what you're capable of. So I think everyone owes themselves to give it an honest shot and see what happens.
Yeah, exactly.
And would you say that you enjoy the building part or the breaking part more?
I think both. I heard a lot about you can build or break only. You can choose, but I think it's not true at all because when you build something, you need to be, yeah, you think optimistically about your code. People usually, oh, but it's a good code. And why are you trying to break it? Be a bit offended about it. But when you build something for Web3 and he build smart contracts or build a very dangerous part of the system in general. So if it breaks, it will be very bad for the whole community. Not even for us, yeah, it's like for the whole community in general. So you're a bit more concerned and you're also thinking about security. So you take a bit of this side. If you're not taking security uh, as important part of your job as a builder, you do something wrong, I guess. And when you're doing security, you also think you need to be a bit of builder because you need to understand what is feasible, what is, if you over engineer and what is attack vector on it, you need to take all of this consideration together. Even so that it's a different job in general when you type code and when you do review and then try to find a bug. But still the mindset, it's a bit shared between different roles.
And do you think that being a developer helps you when you're looking for bugs?
Definitely, yeah. I guess so. For me, some cool bugs that I found, but not all of them. Some of those like spontaneously just looking into code and yeah, makes sense. But for some, I was writing something and see, wow, it's a very dangerous part. I just almost miss it, and okay, probably someone miss it. And yeah, there's the people who actually take a look into code and the exact bugs that you made, uh, they can find it on other like yeah, smart contracts. So it also was a case for I think Starkware bug that I found. It was an issue that I was writing a contract and write a contract and see, okay, I missed a small bug, but it's okay, I will fix it. Spent a bit of time on it, but then probably someone else has this bug and took a look into DeFi contracts and other rollups and think, okay, this is Starkware, and they have this bug in new version of smart contract. So just wrote to them and saying, guys, take a look, and they approve it as well. So it's how building stuff can help you to be secure because you have all this consideration from, when you start building each part that you have problem with, and you know how builders think with each of stuff.
Yeah, I think that's a great approach to it. And would you say that you need a minimum level of security experience to be able to develop sound contracts? And how would you go about getting the level of skill as a developer?
Mm. So when you're a developer, you need to be very technical, like technical as much as you can be. But when you do security, I guess you can miss a lot of parts and it's fine. Also a case, for instance, for a complicated system. You can be not technical, you can just understand a bit of syntaxes, but you can find a logical bug. So it's not directly connected because it's actually about a different skill. Uh, but if you're technical enough, it helps you to understand system from the very beginning, and it helps you to find and like a different bugs that other people cannot to find.
Yeah. And can you tell us a little bit about this bug you found in OpenZeppelin? How did that happen? And what was it?
Oh, so there was actually three bugs that I found. This was like one by one. It was one crazy week that I was looking into OpenZeppelin library. It's actually the first week that I started. For the first bug, I described the story how I found it. For second and third, I think that I was just looking more into code and try to find another bug because I was feeling that now I can catch all of them and actually, yeah, break to different parts. The problem for the OpenZeppelin library back then, it was um, the Solidity versions that they changed from 0.7 to 0.8. And when they changed the version of Solidity, the ABI encoder also changed from version 1 to version 2. Because of different checks for ABI encoding, ABI decode works differently. And so basically, it's reward if you try to get a Boolean value. So you just try to decode and try to decode Boolean value, but it's not Boolean and it's reverse. and previously it was not the case. It was simple backend, solidity semantics and syntax that anyone could found, but for some reason it was in the contract for a long period of time. And I guess also because people was like, oh, it's OpenZeppelin. No one could find bug there, right? It's good reputation that help people to obfuscate security. And also the bug was not critical. So it was like more engaged to me that you can find something medium or high severity bug, but still it's important for industry to take um, high level of quality for such important libraries of OpenZeppelin. They also, yeah, were like really great in communication and very quick in responding. I had so great experience with them.
And what about the Starkware bug? What were you building that you kind of realized someone could have missed it?
Yeah, because it was tricky back with Merkle tree, and it's something that, I just tried to build Merkle tree verification, and for some reason, I couldn't just use OpenZeppelin libraries to usually prevents a lot of hacks. But I was needed to build something specific because we have the same version of Merkle tree in zk circuits. So you have two different versions, and what is easier to build, you just build it. And I missed one of check, but very important. And actually, you could, make some kind of double spend. And yeah, I quickly, realize it and fix the bug. But at the same time, when you think about such a, you know, tricky bug when you have a Merkle tree, but there's a double spend because of one missing check. And when I initially developed it, I was like, no, it will be fine. It's like I prevent and make all of the checks. I was just not thinking about one specific scenario. And I think that other developers could also miss it because the kind of thinking when you develop is more optimistic. You're thinking about it should work and why it should work, and tests are passed, and it's everything is okay. Uh, but yeah, it's like what I missed. I could just replace it to another project and see how it will look like. And I just found it, yeah, in the code base of Starkware.
Yeah, that's cool. And how do you think of those different scenarios? Because when you just mentioned that you're a little more optimistic when you're building, and how do you switch to being pessimistic, and how do you come up with different scenarios where things can break?
I think it's different incentivized mechanism for your brain because when you develop, you want to see your products, finished and in a good sport, good quality of code, and actually running, and provide some value for industry. But when you're breaking something, the only thing that you want to achieve is to actually find a bug and actually to break the system. So I think that with this incentivized mechanism, my brain starts thinking in a different direction. So I want to get this goal, and I want to find the bug because I know that people will respect me for finding bugs, and also it's something that my goal is in general when I try to break. So yeah, my brain's thinking about different direction. It's something that is natural way. It's bringing its
That makes sense. And when you're building, do you usually have a period of time where you're in that optimistic mindset and then later on you switch and you try to break it, or something that you change on the go as you're building?
um, yeah. So I mean, I think that. What I do is when I'm building, I just actually write a code and make a specification for it, and yeah, that's it. So, but then I was going for a walk and thinking about code. If I can, it's actually helped me a lot. And usually I hang out with friends, and then you can just speak with about something, but your brain thinking about direction of hacking, and some crazy idea just pop up in a random moment of time. So it's like, yeah, because you know the structure of the code, you know all the invariants that you want to hold, how EVM works and Solidity, and then you just get it all together with one creative idea how you can break it. And it's more like this process of creativity when you need to spend more time, but not actually to thinking and writing something.
Yeah, no, I think that's a common thread among many security experts that they found their most interesting bugs when they were like in the shower or going for a walk. There's something about just letting your mind work in the background without actually being looking at the code that when you're like unencumbered, just relaxing and something comes to you, you're like, oh, I figured it out.
Yes, exactly. I started doing code for Ina for like years ago, and we did it with my friend together, and he's like very smart guy. Uh, did a lot of Olympiad and computer science stuff, so he knows a lot about algorithms and data structure, how computer works, and all of this. And I really like the process of breaking contracts all with someone, not being alone, because you can share the ideas, and it's actually what we are doing. Yeah.
Yeah, no, I think that's definitely something to being able to bounce ideas back and forth and having someone to share that experience. On that theme, what is your favorite part about working at zkSync?
Um, It's actually, yeah, breaking stuff. It's the same for, so I think that this creative part where you think about security of the network, it's actually very different from competitive audit and bug bounty, because when you have one system for a long period of time and you think about security of the network, you think it in a different way, because when you try to break it, for instance, on Immunify, right? The only incentive that you have if something is almost broken, but not, you will not even send and report, because you know that you will not get paid for what you will send it, right? And for Code Farina, you will know that it's low severity, so it doesn't make sense for you. But when you're developing the project, you need to think more about, okay, it's right now it's not something suspicious, but probably in future it will be. And yeah, so it's basically what you need to think about. So you need to think more about attack scenarios. You need to think about attack vectors, threat model, design of the system. You need to be very careful with what you implement and how it will be implemented, how it will change in future. So it's more like connected.
Yeah, and if you had to choose between only building something or only trying to break a protocol, would you choose to only try to break it if you had to choose between one or the other?
I think it's more about breaking right now, but it also depends. I'm really enjoying building something. It's when I hack something and when I um, try people to make design better. So I also spend a lot of time for comments like, you can implement this function a bit better. You can add comments here, and what actually audit company do, right? So it's like when you do an audit, you also need to provide some suggestions, improvements. You put some raw notes, but not only finding bugs. It's all about
Hmm.
security in future. So it's a continuous integration with the security design, instead of just trying to solve all the problems right now and saying, oh, it's almost broken, but it's fine because there's some implicit check in between, so you don't need to care. And yeah, it's what's the difference I see.
Yeah, so you like to take a holistic approach to security instead of just finding one thing that breaks and that's it. You like to look at the system as a whole and try to make it as secure as possible and as future-proof as possible.
Yeah, of course, because it's how mature system should look like, right? Because I had this example on Twitter. Someone posted about Boeing that there's four engine, and if one engine, or like if two engines broken, two will be enough to actually continue flying in a safe mode. And it's crazy because it's something that I want to see more on rollup on smart contract side, because people instead saying that, yeah, I mean, if multisig is broken, we are broken as well, it's fine, but it's not fine. It's like you take the assumption of the system much more than you should do. And you also not to try make design safe, but you want to make implementation safe. So it's all different ideas. And I want to see more about all of these design decisions that people do. I want to see smart contracts that say safe on the design, try to be safe on like have a security in depth where they want to prevent every possible bug on different layers from the implementation to design to all, even like assuming that there's a bug in some core parts of the system, they will have some uh, even like circuit breaker or some helps to escape funds or all of this.
Yeah, and I think that's a good point that I don't know if you watched the talk between the Cotarina, Sherlock, and the auditing firms CEOs, where they were debating, and one of the main topics was that the auditing firms they provide is holistic overview of the protocol, whereas the audit contest, it's more on that idea of trying to break it and only finding the most severe problems, but then possibly missing things that could lead up to bigger problems down the road. And I think it's something cool to highlight that it is a different mindset and it has implications. And it's cool that you like to think about on the holistic side, and that's probably a very good thing for zkSync.
Yeah, but in general, we do both. We try to do a competitive audits like Katrina because it's different incentivized model, right? We also want to have a bug bounty program as a final step if something go wrong and people actually find 0 day. We want to have incentive to actually report to us, but we also do audits and we have independent security researchers as well, and we do design review internally. We want to have everything together, or even like monitoring for the network. Um, because if you just miss some part of it, you will be not safe because all of these parts discover different systems. Like if you want to be secure on the all the layers, you need to think about all the implications and you'll use all the people that can help you. So it's like, yeah, you want to have all these crazy ideas from code free now there's this one unique bug and no one can find it because incentivized models think if you find one unique bug, you get paid very well. And on Immunify when 0 days and just popping up on all of these projects. And yeah, it's like, or audit film that helps you to secure code by design. So it's like, I think all together and what we try to do.
Yeah, I think this layer approach is definitely the best way to go about it and make sure you have as many layers as possible on the security stack of things. Yeah, it was a pleasure to have you here. It was really good to talk to you and hear all about your experiences and how you came to be where you are at the moment.
Some I think it's a connection with internet just